I think that's all from us. Thank you for watching our videos.
The history of brake system began when wooden brakes were made. In 1902, Louis Renault, inspired by a theory, invented the mechanical drum brakes to replace wooden brakes. In 1918, Malcolm Longhead invented the hydraulic brakes which require less stopping force. Later, the hydraulic brakes were implemented with disc brakes which was invented by William Lanchester in 1902. In 1920, anti-lock brakes were invented and later adapted into cars in the 1950s. The timelines and milestones of brake system technology began in the 1800s. During this time, brakes was made of wooden blocks. In 1899, Gottlieb Daimler had come up with a new idea for the brakes. In 1902, mechanical drum brakes were invented by Louis Renault, inspired by the idea of Gottlieb Daimler. Later, expanding internal shoe brakes were developed into the mechanical drum brakes. In 1902, William Lanchester invented disc brakes, but they were not popular. In 1918, Malcolm Longhead invented hydraulic brakes. In the mid-20th century, disc brakes were implemented with hydraulic brakes. In the 1920s, anti-lock brakes had been invented and used by aeroplanes. In the 1950s, anti-lock brakes had finally been adapted into cars.
Current technology of brake system. There are several current brake system technologies including hydraulic braking system, electromagnetic braking system, and the most recent automatic brake system. These systems are currently widely utilized. The first one is hydraulic brake system. Hydraulic brake system is a braking device that transmits force into the system by using brake fluid. The fluid is responsible for transferring pressure from the control mechanism to the braking mechanism. Hydraulic braking systems are used in low-speed four-wheelers. It works with the drum type, but practically all autos utilize the disc type. It's also found on some motorcycles. Some Pulsar front-wheel brakes employ single-acting hydraulic bags, but dual-acting hydraulic bags are used in practically all of the scenarios listed above. How it works. Pushing the brake pedal activates the hydraulic braking system. This will depress a piston in the master cylinder, causing fluid to flow down the pipe. The fluid flows to each wheel sleeve cylinders and fills them, driving the piston out to apply brakes. Next is electromagnetic brake system. Electromagnetic braking system feature in many modern and hybrid vehicles. To accomplish frictionless braking, the electromagnetic braking system employs the electromagnetism principle. This extends the life and reliability of the brake. Furthermore, traditional braking systems are prone to slippage, whereas rapid magnetic brakes support this. This technique is popular in hybrids since it eliminates friction and the requirement for the lubrication. It is also fairly small in comparison to typical braking systems. It is mostly utilized in trams and trains. How it works. Electromagnetic brake system work when electromagnetic brake is actuated by electricity but transmit torque physically. When the brake reserve power or current, the coil is activated, resulting in the formation of a magnetic field. This field converts the coil into an electromagnet, which generates magnetic flux lines. The armature is drawn in by the magnetic flow. Typically, the armature and hub are positioned on the spinning shaft. The coil's attraction to the armature and hub quickly brings the shaft to a halt, causing fast current to flow in the opposite direction. Next is automatic brake system. Sensors and brake controls are used in automatic braking technology to assist prevent high-speed crash. Some automated braking systems can prevent crash entirely, but the majority of them are designed to just slow a vehicle down before it collides with something. Because high-speed collisions are more likely to be fatal than low-speed ones, automated braking system can save lives and limit property damage during an accident. How automatic brake system works. Each automotive has its unique automated braking system technology, although they all rely on some kind of sensor input. Some of these devices employ laser, others radar, and still others video data. This sensor data is then utilized to identify whether or not there are any objects in the vehicle's path. When an item is identified, the system can assess whether the vehicle speed is higher than the speed of the object in front of it. A considerable speed disparity may suggest that a collision is imminent, in which case the system can immediately apply the brakes.
The anti-lock braking system (ABS) has evolved from a choice to almost a requirement. Anti-lock brakes help drivers maintain better control and come to a complete stop more quickly while braking suddenly or on slick roads. The technologies use sensors to track each wheel action separately. Then the brake pressure is adjusted to prevent relocking and slippage. There are many reasons why a hydraulic system is reliable power transmission. First, it is simple to start, stop, accelerate and decelerate, thanks to its simple levers and push buttons. Accurate control is also made possible by this. It also handles a wide range of weight with ease because it is such a fluid system without any heavy gears, pulleys or levers. Regardless of changes in speed, it exerts a constant force. Hydraulic systems tend to be straightforward, safe and affordable since they have fewer moving parts than mechanical and electrical systems, which make them simpler to maintain. Because they do not produce spark, hydraulic systems are secure to use in mine and chemical facilities. Increased stopping power, especially on wet surface, ABS technology considerably reduce the possibility of your wheel locking up and your car skidding, especially in slick circumstances. It is not an exaggeration to state that this can save lives by assisting drivers in keeping control of their vehicles and steer clear of potentially hazardous situations. Decreased stopping distance, anti-lock brakes shorten braking length by prevent tire sliding which waste space. Compared to other braking options, electromagnetic brakes offer a number of advantages such as decreased wear. In mechanical braking system, the amount of friction needed to reduce or hard load can result in severe long-term wear and tears on the brake pads. Electromagnetic brakes contribute to a reduction in wear by using electromagnetic force and well-chosen friction material to give the slowest stopping action. Improved efficiency, a tailored electromagnetic brake can offer quick response, exact engagement, and flash-free operation. Next, cheaper price electromagnetic braking solution last longer and require significantly less maintenance since they lessen component wear and increase brake efficiency. Improved heat transfer compared to mechanical system and other options. Well-designed electromagnetic braking systems can be quite effective at dissipating heat. Disadvantages of modern technologies compared to earlier technology: stop time irregularity despite having ABS. Some drivers claim that the time it takes for the vehicle to come to a complete stop varies gravel or snow issues. Anti-lock brakes improve safety and control on most highways. Also, they make driving through snow or gravel slightly more challenging. Maintaining and caring for a small amount of maintenance, such as regular sensor inspections and perhaps sensor replacement may be needed for anti-lock brakes. Having said that, this maintenance is normally quite minimal unless you frequently travel in poor weather. There are various issues with hydraulic system as well. It can be difficult to handle hydraulic fluid and it can be challenging to completely stop leak in hydraulic system. In heated region, hydraulic fluid that seep could ignite hydraulic line that rupture can result in significant injury. When handling hydraulic fluid, exercise caution because prolonged exposure might have negative health effects. However, some varieties of hydraulic fluids are less corrosive than others. For hydraulic mountain bikes, DOT fluid and mineral oil are the two primary types of braking fluid that are available. Mineral oil non-corrosive qualities make it less prone to damage a bike paint job. Regularly check hydraulic system for leaks, loops as necessary and maintain your hydraulic systems to keep it in top condition. Electromagnetic braking system using magnetic power and electronic, so the battery degrades significantly more quickly when the brake system is run only on battery power. As the current generation is slow at low speed, making them less effective.
New and future technology brake system. Introduction about a brake system. Brakes are one of the most important functions of vehicle safety system. The future goal of vehicle braking system is to develop intelligent, integrated braking system. System now still focus on mechanical functionality with hydraulic power transmission and vacuum brake booster. Vehicles are equipped with electronic safety features including automated braking system (ABS) and electronic stability control (ESC) system that actively support driver intervention in hazardous circumstances. Advantage of new brake system. It can help to reduce CO2 emission as well because of lower particle emission during friction braking. Braking must be electronically enabled in the future and must not add to environmental problems. This will help to make vehicles more lighter. Lighter vehicles mean less drag as the vehicle brakes. If the drag on vehicle is decreased, brake system can be made more modular and scalable. The aim is to replace the hydraulic system with software function that can run on high-performance computers. The new and future of braking system is electromechanical braking. Electromechanical braking, or the short form is CMB, also known as a brake-by-wire system. It has no hydraulic fluid, it is easier to assemble and less harmful to the environment and less complex than hydraulic brakes. It also has no connection between the AMB units and the brake pedal itself. The vehicle is quieter on the road and it doesn't experience reverberation. The MK-C1 master cylinder, which is electronically regulated, can lock the brake in 150 milliseconds, and this is more quick and safe than the old version.
In conclusion, brakes are vehicle components that absorb the energy released by a moving vehicle in order to bring it to a stop. The braking mechanism in automotive is very important in reducing accidents and deaths. We can observe that braking system technology is improving with time as automobile manufacturers strive to prevent accidents on the road. There are also several braking systems developed to replace the existing brake system. This has the potential to increase car safety in the future. That's all from us. Thank you for spending your time watching our video.